Hello everyone, my name is Sai Krishna and today me along with Varshit and Lalit are gonna explain you about some problems in flat. So let us check our first question. Our first question is about designing a DFA to check whether the given decimal number is divisible by 3 or not. So before designing our actual DFA, let us check what are the reminders which we get when we divide the decimal numbers with 3. So here it is. And we know that when a number is divisible by 3, its remainder is 0. Like when we divide the number by 3, the remainder is 0. Only in that case, the number is divisible by 3. So let us check here. So 0, 3, 6 and 9 produce the remainder 0 when divided by 3. So these are the numbers which are divided by 3, and 1, 4 and 7 gives us the remainder 1 when they are divided by 3, and 2, 5 and 8 give us the remainder 2 when they are divided by 3. So here we are getting 3 possible reminders. So let us first draw 3 possible states, Q0, Q1 and Q2. So let us assume that the Q0 state corresponds to the case where we get the remainder 0, Q1 case corresponds to the case where we get the remainder 1, and Q2 state corresponds to the case where we get remainder 2. And we know that a number is divisible by 3 only if the remainder is 0. So we are making our initial state Q0 as final state also. So and here we can see that 0, 3, 6 and 9 are the numbers which are divisible by 3. So when we give the initial input 0, 3, 6 or 9, they should also end as its final state. So we are giving it a self loop to Q0. Next. So when uh, the numbers 2, 5 and 8 are divided by 3, we are getting the remainder 2. That means they should be sent to the state Q2. And when 1, 4 and 7 are divided by 3, we are getting the remainder 1. So they should be sent to the state Q1. Okay. For the initial state Q0, we have given all the input and all the possible cases. So as it is DFA, every state should have every input case. So for Q0, let us check. So assume that we have reached Q1 by giving an input 1. Okay. And next, let us say after 1, we are giving input again 1. Let us say we are giving a number level as an input. So with first one, the control reaches Q1, and again when we give 1, so 11 divided by 3 gives us the remainder 2. So that should be sent to Q2. So we keep an input 147 through Q0 that goes to Q2. So next, and when we so let us assume we have given 1 and our next input is, let us assume 2. So 12. 12 is divisible by 3. So the set 2, 5 and 8 on input in the state Q1 should are the numbers which are divided by 3. So they should go to our final state, that is Q0. So we are giving it to Q0. And let us assume we are giving a number 19. So 19 divided by 3, we are getting the remainder 1. So like see, first we give 1 to initial get Q0, then we reach Q1, and when we give 9 over here, that becomes 19. So the remainder is 1. So remainder 1 means that is Q0. So we are giving a self loop to Q0, Q1. Sorry. So we have given all the possible inputs for Q1, and let us now check for Q2. So when so let us assume that we are giving a number 119. So 119 when divided by 3 gives us the input, like gives us the remainder. So let us assume we are giving the number 119. So initially from Q0, when we give the input 1, it reaches to Q1, and again when we give the input 1, it reaches to Q2. And when we give 9 at Q2, which is 119 divided by 3, the remainder is 2. So it should end in the state Q2 only. So we are giving a self loop. And so you can also check with these numbers 110, 113, or 4, 4, 3, 7, 4, 6. This all results in the remainder 2. So we are giving it a self loop to Q2. And let us think of a case where we give 1, 7. So 1, 7, and 2. So 172 divided by 3 gives us the remainder 1. So it should go to the state Q1. So let us allow it. So you can check these numbers also, like 7, 1, 5, 4, 7, 8. These all gives us the remainder 1. So we are sending it to the state Q1. And we have given 258, we have given 9036, and the remaining inputs that we should give to Q2 are 147. So think that we are giving a number 111 as an input. So 1 goes to Q1, and again 1 goes to Q2, and again 1. So 111 divided by 3 gives us the remainder 0. So that should end in the state Q0. So we are giving it the input 147, that goes to the final state Q0. So here it is. This is the solution for the given problem. Thank you.
In the question given that design a milli machine that uses its state to remember that last symbol, read and emits output Y whenever current input matches to previous one and emits N otherwise. So milli machine means it is a FSM which depends on present input and present state. In the given question, if the if the current input matches with the previous input, then we should give Y as output. Otherwise, we should give N as output. So let us take Q0 as initial state. For Q0, input as 0 to Q1, output is N. For Q0, input as 1 to Q2, output is N. For Q1, input as 0, output is Y because it matches with previous one. For Q2, input is 1, output is Y because it matches with previous input. And for Q2, input is 0, output is N because it does not matches with previous input. And for Q1, input is 1, output is N because it also does not matches with previous input.